So what if this time we have a more complicated situation, and instead of just having two objects, we have three of them? Well, it's a similar rule. We are going to look at the moments on the left and the moments on the right, and with that, we are going to try to make a decision about whether or not it balances. So let's draw an imaginary line that divides this space in two, like so. And then we're going to find the moments on the left and the moments on the right. So let's start with the moment of this object we're going to call 1. This one we're going to call 2, and this one we are going to call 3. So the moments on the left are the moment of object 1, which has force 1. This one has force 2, and this one has force 3. Now, the object that we call 1 is at a distance that we will call, you guessed it, d1. And the object 2 is a little bit closer. It is at a distance here that we will instead call d2. So, to find the moments on the left, we do the moment of object 1 is going to be f1 times d1. And the moment of object 2 is going to be f2 times d2. To find the total moment on the left, we're just going to do m equals m1 plus m2. Now, to find out whether this balances out, all we need to do is compare it with the moment on the right. And the moment on the right is going to be, again, we need to define the distance from here to the object, which we can call distance 3. And so it's going to be m3 on the right, and m3 again is quite simply the force times the distance. So once we found m1 plus m2 on the left, once we found m3 on the right, we just compare them. If they're equal, then it will be balanced. If m3 is larger, then we'll see this pivot clockwise. If m1 plus m2 turns out to be larger, then it will pivot counterclockwise.